Good morning or good afternoon, depending on where you are in the world. My name is Kathy Kroll. I'm a co-director of technology transfer for the IBT ABC UTC at Florida International University. We'd like to welcome you and approximately 1,300 other registered sites today to our 178th webinar in the monthly webinar series. Today's featured presentation is Minnesota DOT Innovates, Modernizing Bridge Management with Digital Twins and Artificial Intelligence. Ed Lukin and Jennifer Randall with Minnesota DOT and Barrett Lovelace with Collins Engineers will be presenting. We'll start with a few announcements and then move on to the featured presentation, which will last approximately 40 minutes and will be followed by a question and answer session. I'd like to start with a thank you to the U.S. Department of Transportation and its University Transportation Program that sponsors the IBT ABC UTC. The University Transportation Centers program has been in existence since 1987 with the mandate to help address our nation's ever-growing need to maintain and enhance our transportation systems. The IBT ABC UTC at Florida International University and our partner universities are focused on accelerated bridge construction and innovative bridge technologies. We'd like to express our appreciation to the US DOT and their UTC program for supporting the IBT APC UTC so that we can continue to serve the bridge engineering community with events like this webinar series. Before we get started with today's webinar, I'd like to share a few announcements. First, the 2026 World Bridge Engineering Conference that is coordinated by the IBT ABC UTC will be held in Miami, Florida, the 1st and 2nd of 2026 in December. This conference is co-sponsored by the US DOT and over 32 state DOTs. We're currently accepting abstract submissions. The deadline is March 20th. For additional information on all things related to the conference, please visit our website and/or use the QR codes that are on the screen. In addition to abstract submissions, we're also accepting award nomination submissions for the Innovative Bridge Engineer of the Year, Innovative Bridge Owner Agency of the Year, and project awards for both the ADC and IBT in the categories on the screen. The deadline is June 30th. Again, see our website and/or use the QR codes on the screen for additional information and submissions. On to our industry events. The 2026 PCI convention at the Precast Show is coming up quickly. It will be held February 2nd through the 6th in Kansas City, Missouri. Registration is open. The AISC NSPA 2026 Steel Conference will be held April 22nd through the 24th in Atlanta, Georgia. Registration is open. The 4th International Interactive Symposium on UHPC will be held in Des Moines, Iowa, June 14th through the 17th. Anyone who is interested in UHPC, this is a very valuable conference, so put it on your calendar. The AASHTO Committee on Bridges and Structures annual meeting will be from June 28th to July 2nd in Charlotte, North Carolina. Next, we are using the industry slide, the industry news slide this month to solicit feedback from you on the monthly webinar series. What topics or projects would you like to hear about? So please send me ideas. My email address is on the screen. We're particularly interested in international presentations so we can learn from best practices around the world. For interest, roughly 10% of our listening audience is international. Again, help us keep it relevant and send me any ideas that you have. Again, my email address is on the screen. Continuing to our own events, next week on January 30th, we'll be holding our quarterly research seminar from 1 to 2:15 Eastern. The featured project will be predicting key bridge characteristics using machine learning. Our colleagues from the University of Washington will be presenting. Registration is open, sign up now. Our next monthly webinar will be on Thursday, February 19th from 1 to 2:15 Eastern. The presentation will be Delaware DOT Accelerated and Innovative Entirely Precast Bridges. It's about a pair of bridges on US 13 over Blackbird Creek. Kevin Lindell and Nick Dean from Delaware DOT will be presenting. Registration is open. You can sign up now on the IBT ABC UTC website. That's all for our announcements. On to our standard housekeeping items. As many of you may know, these webinars are recorded and posted on the IBT ABC UTC website in the section titled Monthly Webinar Archives. So you can access this and all previous webinars for future learning and to share with interested colleagues. I'd also like to point out that a PDF version of today's presentation is provided in the Go-To dashboard on the right side of your screen. You can download these PDFs during the training session. They will also be posted in the archives. I re-emphasize this resource. We sometimes have latency issues where the audio and video are not well aligned. If this is your experience, we encourage you to download the presentation and follow along in real time. Lastly, this presentation will be followed by a question and answer session. With that, we'll begin our featured presentation. Happy to welcome Ed Lutgen, the Minnesota State Bridge Engineer, Jennifer Randall, the Minnesota State Bridge Inspection Engineer, and Barrett Lovelace, Collins Engineers VP of Emerging Technologies. Ed will kick us off with an introduction, followed by Jen and Barrett presenting on Minnesota DOT's innovations in bridge management through the use of digital twins and artificial intelligence. Thank you, Ed, Jen, and Barrett, for sharing your time and expertise with us today. With that, we'll turn the screen controls over to the presenters.
Well, good morning or afternoon. Thanks, Kathy. Appreciate it. Today, we are going to present on some innovative solutions for how MnDOT modernizes our bridge management using digital twins and AI. I want to thank Jennifer Randall, who leads our bridge inspection unit. I also want to thank Barrett Lovelace, who works for Collins Engineer in the local office and is a national leader on drones, digital twins, and AI. We've been working with Barrett and Jen using drones for bridge inspections through either research or projects for well over 10 years. Digital twins and AI is just the next natural progression. Thanks to both of them, as MnDOT wouldn't be where we are today without them. Some of the topics we will include, you see on the screen. I'll include some basic MnDOT bridge information and from our bridge office. Jen will cover digital twin overview, night inspections, and IR. And then Barrett will cover a culvert example using AI for defect detection, how we can use AI for training, then go into an example project from our historic Robert Street Bridge, and lastly cover our benefits. At the end, we'll cover some questions that might come up during the presentations. For those unfamiliar with where Minnesota is located, we're part of the Midwest part of the country. Today we have 3 seasons here in Minnesota. We have 3 seasons. We're now in the winter season. The next season is the pothole season. That's the spring season. Then we have the construction season. Tonight we have a brisk temperature of minus 20 degrees below zero, so without windshield. So that's so we frequently use de-icing materials and chemicals. So we have to consider that as we look at our bridge condition. A little bit about our bridge inventory. We have a state statute that defines a bridge which is longer than 10 feet. So we manage over 21,000 bridges. We have a little over 77 million square feet of bridge deck area. So it's a pretty large state system within our state. The bridge office, MnDOT bridge office, has about 140 staff. We have six final design units and 1 preliminary unit. Approximately 50 to 70% of the program is done in-house. So our final plans are developed quite a bit substantially by our internal staff. As far as for in bridge inspections, we very much have a decentralized bridge inspection program with over 350 team leaders that are located throughout the state. Local agencies perform all their own bridge inspections, which can be done either by consultants or in-house staff. But approximately 70% of local agencies are done by internal staff and the other by consultants. For the state system, the districts perform all the routine and initial inspections as well as quality control. And then the bridge office, in the centralized bridge office, we have 7 staff that work on bridge inspections. And so they do all the in-depths, all the complex, all the NSTMs, as well as the training, certification, the NDT, quality assurance, all the policy pieces, and any innovative work like digital twins and AI. And I'll have Jen take it away.
So I am the head of our NSTM unit in the bridge office and have been so for the last 20 plus years. Barrett, I don't see the slide advancing. So I guess we're calling this the birthplace of UAS, but I'm sure there's other states and countries that have started this way before us in regards to bridges as well. We did start this in 2015, and basically it was just a kind of a fun thing that Barrett shared with me. Me and Barrett have been working together for many years now, and it was the end of a research phase of the fiscal year, and there was some leftover money that needed to be spent by our research department, and Barrett showed me there was a thing at the University of Minnesota, like a talk or something going on there about farmers using drones to monitor their crops. And we thought, wow, maybe we could do this with bridges for inspection purposes, you know, having a flying camera on places that we can't usually get to if we don't have a snooper or an underbridge inspection vehicle, that is. And we thought it was something that would just be fun, play with a toy or whatever would be a good idea to just see. But we were soon met with stop signs, one being the governor and our aeronautics department saying, wait a second, we need to do this right, you know, because there's privacy issues, something that we don't really think about too much in regards to bridge inspections. You know, we're looking at a bridge, we're not looking for people or looking at people, but they had that concern. So we started out very slowly, which is why we did 5 research phases since then to get where we are today. We started out very rural. This was before Part 107 as well, so we had to have actual licensed pilots fly the drones for us. And it was great to have our aeronautics office give us that oversight in the beginning, and continues to do so to this day, so that, you know, we're bridge inspectors by nature and our engineers, and we're not thinking, you know, we're just flying something up with a camera to see bridge deterioration. So that really helped us. We were also very open about what we were doing to the public. I did a lot of public relations interviews, and we started out very rural with the bridges, nothing in the metropolitan area. And the overall, which ended up being great for us because our overall feedback was that it was very positive. The public really liked that we were doing this. There wasn't any really threat of, you know, privacy issues. Most of the time, if we were out flying, it was people were curious and seeing what we were doing, and just overall wanted some better knowledge of how we were using this new technology to inspect bridges in a safer way. And so far, over 3,000 bridges have been inspected by drones in our state, and over 300 digital twins have been created, mainly on our bigger sized, more complex bridge structures. The federal highway also was very important in our involvement in the beginning. I was part of the Everyday Counts EDC 5 committee in DC back in 2018 when this started. That was headed by James Gray. I believe Hoda Azari, that is on the call too today, is involved in that. So they've been very instrumental with us moving forward as we've gone through these research phases and implementation to where we are now. Collins has been our go-to consultant that we utilize to help us go through these phases of research, keep up with the technology, and they have since then. Barrett has been he's their UAS coordinator for the department, for their consultant group, and they've conducted bridge inspections with UAS almost in every state now. So it's become a really big thing that has what we thought was going to be a little fun project into something way bigger than we ever thought. So digital twin is what we're here to talk about today, is a digital representation of a physical asset. As you can see in the video here, that puts out 3D point mesh, or 3D point clouds or mesh. They're geospatially correct. So in that way you can measure items or defects on the bridge. You can annotate or add notes, and you can share the link to other people across the department or whoever you're working with, the bridge owners. So it's just a great way to share information that we as inspectors see in the field that can be better demonstrated instead of still photos like a camera. Okay, digital twin inputs. This can be done either by drone or just what you have for your cameras. We collect data with drones and cameras and can include ground control, points or QR codes to post-process the information. We also include asset information such as inspection, testing, or information or inventory information inside of these digital twins as well. And with the ground control points, we can get into less than 1/8 of an inch accuracy, if not to the even tighter. With us, we do not need LiDAR for these. The ground control points work good enough for bridge inspection purposes. So these are drone footages that we do not use LiDAR with. So here's a digital twin data collection. We can use these as well for pre-planning UAS missions or pre-planning inspections by utilizing drone footage. The Skydio 3D scan here is an example of using artificial intelligence for data collection. So Skydio is the brand of the drone that is manufactured in the United States. The U simply defines a volume to scan, as shown here, and the drone explores that space, calculates what needs to be scanned, and performs the scan autonomously. The grid represents the object to be modeled, and then the color changes from yellow to purple as data is collected. And with any of these can be manual missions, they can be autonomously done. Your overlap, though, with either camera or drone has to be 70 to 80% overlap to get a really accurate depiction of the bridge without any gaps or spaces in it. Okay, this is an example of a complete digital twin of a bridge, demonstrating how we can manipulate the model to see the underside of the deck and measure defects. Not seeing the video move along too fast yet. But as you can see, this is the Bentley iTwin Experience software. Here the bridge is going now. And you can add information on the digital twin by adding, element notes, any kind of note. You can move it around. You can see from up underneath the deck. It's kind of like the little Google guy or Google Maps. You put the guy on the roadway and you can walk around and look. It's the same kind of concept. And what's nice about the Skydio drones too is that they have sensors that can get up close to the bridge without hitting the bridge. So they have object sensing avoidance. And you can see here, this bridge is not in that great a shape. And you can see there, we're measuring out an area of spalling that has happened for underneath the deck. So it's very important for bridge inspections. We need drones that have cameras that can look upward as well and have obstacle avoidance. All right, so this is a video or a 3D digital model of our St. Croix River crossing bridge. It's an Extrados bridge that spans between Minnesota and Wisconsin. And when you look at this, you can think of, if you know the movies of Matrix or the Minority Report movies, that they have digital twins or things in the air that they can manipulate and move around with their hands. It's kind of similar to this. We did that with the HoloLens, Microsoft HoloLens when we had those. It's pretty trippy, but it's like you're there at the bridge and you can see things. And the amount of data that we can get is so much better. You can even do crack detection, as you can see with those blue lines on there. And Barrett will talk more about that later. So it's basically a virtual space where we can visit, meet, and collaborate our findings across many different entities, whether it be if I'm seeing something in the field and I can upload this post-process digital twin, I can share this to load ratings, design, construction, maintenance, and across the different districts so that everybody can see what we see in the field. Because sometimes it's hard to visualize from just a photo. So you don't have to do a whole bridge to have a digital twin either. You can be created for individual bridge elements such as this pier. And this pier supports the Cedar Avenue Bridge in the metropolitan area here, right by the Mall of America. Was just on that this past year. And this was used to help perform a load rating analysis. You can see the imagery here, how great of the quality you get. You can even see the graffiti on the bridge. Digital twins can also be used to show changes over time. This pier is part of the Kellogg Avenue Bridge in St. Paul, Minnesota, and shows the deterioration over a 6-year time period. That's in 2017, and then the next slide is 2023. You can see how much has happened since then. So this is great for capturing images over time without having to go back through inspection reports and lots of files and photos to get an image up that you can see readily. We can even inspect and collect data at night using the Skydio X10 drone. Again, the Skydio drone manufactured, made in the United States, with additional lighting modules that are a payload on the drone itself. And you can see just by this video here how great the lighting is. Not sure if any other states has as many bridge hits as we do, but they usually happen at night. So it's nice to have the ability to go out at night with a drone to get a visual of what you might need to see, or have someone analyze to see if a lane closure or a bridge closure is needed if a bridge is hit. They also can have payloads of thermographic imagery on there. In regards to infrared thermography, it's an overlay showing here on the underside of a deck showing concrete delamination. You can see the areas that are heated up more is less concrete. The colder areas are darker. Next slide is going to show you the infrared thermography showing the entire deck of a bridge. This model here is comprised of around 100 infrared images post-processed into one image. And you can see the areas of delamination by the hot spots where it's more red. That's where you're having your delamination set. And this can be done. You have to do it during certain times of day. Barrett can get into more of that in his later slides. And because you need the deck to be able to heat up to a certain point within the day, so you can get that difference that you're looking at in the photo here. But it comes out pretty well. And with that, Barrett, I think you're up next with the culvert example.
Okay, thanks, Jen. And thanks to MnDOT and Jen and Ed for the opportunity to work on this. It's certainly been an interesting 10 years and a really fun technology to work on, and seeing it grow throughout the country. So for the rest of the presentation, I'm going to talk through a culvert example, talk about how we're using AI for defect detection, how we're using the digital twins to do bridge virtual inspection training. I'll go through an example of a large-scale bridge project and talk about how we're incorporating the technology into one of those large projects. And then we'll go over some benefits, and then we'll go to questions. So this is just another example. This is something we just did a couple weeks ago, and maybe gives us an idea of how we can use this technology on even just routine normal bridge inspections. This is a metal culvert that we did a couple weeks ago, and just to give you some idea of the level of effort, the whole flight was probably about 10 minutes long to collect the data for this, and also just to demonstrate that we can fly drones in these really challenging environments where we don't have a lot of room, but the obstacle avoidance is so good with these Skydio drones, and we have the supplemental lighting that we can even fly through one of these smaller culverts. And this culvert is interesting because it is deflecting quite a bit in the midspan. And so from the model, we can see that deflection. It might be a little bit hard to see in this slide, but we can see how much it's deflected. We can even measure that. And this was collected for a load rating, so we can also measure the cover over the pipe at different spots along the pipe. So getting that information, normally we might have to use survey methods, but we can also do it with the digital twin. The next thing I'm going to talk about is how we're using AI for analysis. And this is an example of a bridge where we just flew the deck, so we're flying over the top. And I would encourage everyone, if you're trying to implement this technology, this is a really good, like, low-hanging fruit way to start, because we're flying over the top of the bridge. It's pretty easy to fly, pretty easy to process the data. And the bridge deck is one of the most important components of the bridge to collect. And in this case, we are able to apply an AI that we helped develop with Bentley, helps us find cracks, quantify the cracks, and then overlay those cracks onto the 3D digital twin. And those of you that are involved with inspection understand this, but this is a fairly decent sized deck, and the level of effort to go out and actually measure all of the cracks on the bridge deck is pretty significant. I mean, I would estimate for this bridge, it would take 2 people at least 2 or 3 days to measure and sketch all of these cracks, but we can do it with AI, in a matter of maybe an hour of the computer processing the data. So it's a real time saver, and we're getting better data as well. Another example, and hopefully the slides are caught up, but this is the Kellogg Avenue Bridge in St. Paul, and it's one of those pier caps that maybe people are familiar with, where the code changed at some point and the reinforcement requirements changed, and so some of these piers had shear cracking at the pier caps, and so we were able to fly it, perform that AI analysis, and then see those cracks right on the pier cap. And you can see from the image too that there are some cracks like along the pipe that probably aren't really cracks. But part of this process is we have our engineers go through and look for those and delete false positives. So sometimes like a joint might show up as a crack, but we can just easily delete those. So we're not completely relying on the AI. We still have an engineer involved to do quality. And once we have these digital twins, there's lots of different ways that we can view and digest this data. The most common way, obviously, is to be just viewing it through our computers, and we can do that. All of these models can be imported into CAD, or we can view them in the iTwin Capture software itself, or we can share it via the cloud on the iTwin experience. But this is a novel way that we can also view them, which is through the Microsoft HoloLens. And the advantage of this is that we're seeing the bridge in the same scale that we would see if we were doing the inspection in the field. So for instance, if we had, maybe we had a load rating expert that was in a different office in another state, and they can't visit the bridge, from a budget standpoint, or just the logistics, or maybe they're just not a field person. They can do this virtual field visit, and it's not as good as being in the field, but it much more closely approximates being in the field, and they can get a sense of the bridge and look at defects and perform their load rating, based on some of this information. So another way that we can view the data is through the Unreal Engine. So if any of you have teenagers like I do, this is the same engine that runs a lot of those video games, such as Fortnite and others, but it's really good at rendering these really heavy data sets really quickly. And so we worked with Bentley, and they developed this Unreal Engine based model that is, almost like we're kind of gamifying the bridge inspection, and we can use this then for training, or just for having our engineers view the bridge and see some of the defects firsthand. And this bridge it's a stone arch bridge in Minneapolis. It crosses the Mississippi River, so being able to get down to those piers to look at things is pretty difficult. We have to go through locks and dams and get a boat up there, or do rope access, and so that's challenging and expensive, but we can do it also in this kind of virtual environment. And another thing that we are developing for the MnDOT state aid group is an inspection platform or inspection training platform where we're using Unreal Engine, and inspectors will be able to go through and inspect 6 different bridge types in different locations, different scale of bridge with different types of defects. And they can go through and answer different questions about the bridge, and they have to rate, some of the NBIs and element ratings. And while, it's still not as good as physically being in the field, an inspector could do training on these 6 different bridges in just a few hours versus having to maybe travel all over the state to get exposed to maybe bridge types that they aren't normally exposed to. So we're really excited about making this public here in the next few months, and provide this training opportunity for inspectors. Another application is using underwater scanning in conjunction with above water scanning. And so this is a digital twin that includes both multi-beam underwater sonar and the above water photogrammetry. And this was a pier that in St. Paul, Minnesota, that got hit by a barge. It's a railroad bridge, closed the bridge, but we had to go in and assess some of the damage, and we did that both with divers and with underwater scanning, and then with the above water, and we combined them. And you can see here, obviously, where the fracture is up above water, but we're tying it to the below water, and we can see pretty easily the extent of that fracture underwater, and then use this to plan the repairs and those kinds of things. So we've talked about some of the different technologies and examples, and now I'm going to go through how we're using this as part of a larger bridge project. And this is the Robert Street Bridge, which is in downtown St. Paul, crosses the Mississippi River. It's a concrete arch bridge. And so we worked on a team with Michael Baker to do a bridge management plan. And our workflow was a little bit different than we normally would do. So the very first thing we did is we went out, captured the data in the field with the drone. We post-processed this information, and how we're doing that is we have these rendering computers that we are using. And so they're like gaming computers that can render this data really quickly. And so we create these digital twins. We did it span by span. And then the unique part of the process is that we did an office pre-inspection. So the same engineers that are eventually would go out in the field just use the digital twins and put as much inspection information in there as possible through the cloud platform. And then once they have all of that in there, then they go do the actual field inspection. And since it's pre-populated, they have, they're just verifying that a lot of the data is correct in the field, and maybe making some small changes to things that they already had, or if there's new stuff that they found that they couldn't see in the digital twin, then they add that to the digital twin in the field. And so there's a lot of efficiencies, and it made the inspection go quicker in the field. And then we use that data to develop a bridge management plan, and eventually we'll do rehab design plans and then construction. So this just shows, how we're doing the normal inspection. We're not trying to replace the field work at all. We're just trying to improve the quality of it and make it more efficient. And you can see one of our engineers, Katrin, is pre-populating the data in the inspection model before we go in the field. And then you can see in the upper right what that looks like after it's input. And Jen showed some of the automated missions. This is one of the spans of the bridge with the Skydio drone doing an AI mission to collect all the data. And it's pretty interesting. In the 10 years that we've been doing this work, it literally went from being really nervous flying close to a bridge and having to be very attentive to what the drone is doing, probably, trying to have really good pilot skills to do it, to now, we are almost bored waiting for the drone to finish But the other advantage is also that the quality is much better because the drone, when it's flying these AI missions, it doesn't miss anything, or it's always getting the enough overlap to create a good digital twin. So this is a pretty big game changer for us to be able to do this work. And then this is what it looks like when the entire bridge is turned on on the cloud platform, and we can see all the spans. And then this is that main span in the center. It's, it looks like a picture, but this is the 3D model. And just viewing this slide, or this picture, we can, have a good understanding how the bridge is configured and what the condition is. And then once all of that inspection data is input into the platform, we can see, all these flags represent a group of inspection notes. And as we zoom in, we can see exactly where they're at. But on the left, we have each one of those individual inspection notes. And on this bridge, we had, thousands of inspection notes because we're doing a very detailed inspection. Doesn't necessarily mean that we had a lot of significant defects, but just a lot of defects in general. And and one of the big advantages is that we no longer have to describe where a defect is, which can be very time consuming. And trying to describe what span it is, what beam it is, or what column, and what is maybe the distance from the deck. So that streamlines that whole process. And then on this slide, we're showing one individual inspection note or defect. On the left, we have our standard information that we always show, which is the inspector, a description of it. In the middle, we can see where we drew out the DLAM or SPAL and get the area, so we don't even have to measure it in the field. We get that measurement through the model, almost like in CAD. And then in the right, we have all of the pictures associated with that spot on the bridge. And we might have 8 to 10 different pictures of any single area of the bridge. And then, we also applied AI crack detection on this bridge as well. And so we can see all of those cracks, even if we're not quantifying it, which we can do, but just being able to see kind of the density and this and get an understanding of how many cracks and what the density is really helpful. We also have trained AI to find concrete spalls, and that was probably the majority of the defects on this bridge. And we can see all of those spalls that it found. In this case, we probably used it more just as a quality control to make sure we didn't miss anything. But it's a good way to see that information graphically. So we have these models, we have all of our inspection data input, but it's important to understand that we still have all of that data in like a database format. So each individual inspection note is in there. We can sort it by who the inspector was, what type of defect. We can understand like how many spalls we have, the total area, information about how long the inspection took. But the big game changer too is that we can use it as a method of quality control. So we have a more senior engineer go through each individual item and do a quality check. And if you do that in a traditional sense, you'd have to do a completely independent field inspection, which is not something we can do. We usually don't have the budget to do that. So this is a good way to introduce quality control in the process. And so some of the benefits, we have a pretty significant cost savings from the inspection efficiencies that I talked about. I think more important, we're seeing cost savings just because we have much better data, and that data is easier to digest. So we're making better decisions about what to do with the bridge. We have a significant improvement in the quantity and quality of the data. And we're using AI to address staffing shortages, but also to attract staff just to make the inspection process more interesting. And then we have safety improvements from less traffic control, less working from height. and then we turn over the digital twin to contractors. So we're seeing savings in that area as well. Now I'll turn it back over to Jen for some lessons learned.
Thanks, Barrett. So lessons we've learned along the way over the past 10 years is implementation is critical. You need to start off slow. Don't reinvent the wheel as well. If other states have done it, we share all of our research and the steps we've gone through our UAS manual. We share all that with other states. I've been around the country quite a bit doing EDC 5 peer exchanges, presented at lots of webinars like such as this or at conferences. We're willing to share whatever we have to help others get started with using drones for inspection purposes. Education component is also important, as Barrett talked about with the training. Just doing your Part 107 too is pretty good information as well. And we found that partnering with other technology providers has been really helpful to us, such as Bentley with their digital twins processing, using our own inspection manual photos for their software to the AI to learn what is a crack and what isn't a crack, helping out with Skydio, partnering with them to make their drones better, because they're asking us, what do you need from us? What do you need in order to do an inspection better? So we find that working with others has been really helpful, such as Microsoft as well, and Fuji. We've been doing that, but we're willing to share anything that we've done over the past 10 years and learned. And with that, thank you.
Great, thank you so much, Ed, Barrett, and Jennifer. That was a really interesting presentation. We did get some great questions that came in ahead of time, and we have a bunch more that have come in during the presentation. Paul Lyles, the former Georgia State Bridge engineer, will be our first moderator, and he'll be assisted by Bijan Kaligi.
All right, we'll start off with some of the questions that came in beforehand, and we have a bunch of them that came in during your presentation, and I think we'll get some more during the Q&A. The first one we have here is, what is a good entry-level approach for bridge owners to start incorporating digital twins and artificial intelligence into bridge programs?
Well, like I already mentioned in our presentation, using it, more utilizing it as a tool instead of just you're going to drone every bridge in that you have on your inventory. Starting out smaller with smaller bridges, getting a feel, just learning how to fly too is very imperative. But that's how we started out, very slowly and on a smaller scale. And once you get familiar enough with that, then you can ramp things up. And like I said previously, don't reinvent the wheel. There's plenty of states out there, including ours, that have already gone through this process, and we can help you along the way to share what we've done.
Okay. All right, Jennifer, you mentioned about how the workflow, more or less how it developed, and you mentioned some of the specific funding. There was a question about, is there any more funding available now?
Well, they had Federal Highway. We started our drone fleet with a Federal Highway grant back in, gosh, when did we get them? Right before the pandemic, like right when that started around 2020. We got a grant to start our drone fleet, which is around 40 drones now. However, obviously, federal grants can't be used anymore for work or drones that are not USA made. So that's an important point that came about just end of this past year. So that's an important thing to know if you're trying to start a drone program, is that you're going to have to only use, if you want federal grants, you'll have to get only USA American made drones.
Okay. This is a pretty broad question here about which emerging technologies will have the greatest impact on bridge inspection practices in the next 5 years?
That's a good question. I think, well, just maybe going back, I think one of the biggest changes that we've seen, which is helpful, is the 3D scan that we talked about. So that, makes it much easier to fly these bridges and get the information for a digital twin. I think going forward, seeing more AI for different defects and training it for other defects. We've there's some that are available commercially, like with Bentley, where we can do crack detection and spall detection. But through their software, we can also train it for finding other defects. In fact, we've trained it just to find gusset plates on a bridge, on a truss bridge. But it's really, kind of unlimited what we can train it for. And I think, it's always important to not completely trust the AI, but use it as another layer to find things and find defects. So, I mean, really every defect that's in the inspection field manual, we could potentially train the AI for. So I think going forward, that's going to be one of the best applications that we can do.
Okay, I'm really intrigued with the underwater thing. I think that'll be really neat. Get that going real good. Okay, is there anything else that you feel is missing in the research? Is there a research gap or guidance standards or anything else that you'd really like to see?
I don't, the technology is pretty mature actually, and we've kind of gotten to the point in the last 2 years where we don't have a lot of the obstacles that we've had in the past. And so a lot of those challenges I think have already been addressed. I think the biggest issue now is just adoption, and where I see what happens is maybe when you start a project with this new method, people, it's maybe difficult because it's a new process and they're getting used to it, and maybe people even grumble a little bit about using it. But what's interesting is every time we do a project, whoever we're working with, the owner or a different consultant or something, they keep asking to add more and more people to have access to the model. And a lot of times it's things that we never even thought of, like endangered species or public involvement, or so people are using this information for almost every aspect of the project. So I think just getting it involved in more projects so that more people get used to it, and then it kind of sticks after that.
Okay, let's go to some of the inspection questions that came in. Have you tried to align deterioration identified on the digital twin with element condition states?
Yeah, I mean, we haven't done so much of that because I'm in the field anyways. This is more for people that aren't in the field if they want to look at it. I know, who were we talking to the other day? But it was somebody's using the digital twins. I think you were saying that, Barrett, that you'd look at this like a pre-inspection before going out in the field, using the digital twin to see what condition states are going to be like out there. And then when you get out there, verify that. As far as it letting us know what it should be, I mean, that would be another technology feat that could happen going forward, to be honest.
Okay.
Yeah, I agree. And the crack detection now, we can classify it based on condition states and get quantities that way. So that's probably the one example where we can do it. But then we can also like physically measure some of the defects when we're back at the office filling out the report. But there's no real automated way yet to populate that information.
Okay. The question here was, how do drones assess severity of yet unseen delaminations? You'd use the infrared. That was pretty interesting. Is there any other thing you can guess to assess the severity of it?
I would say, if there are delams that we can't see in person or in images, then we can use the IR to find them. But I would say that we still want to be out there with a hammer and hitting those spots and verifying them. So that's still an important part of the process, and I think it will be for the foreseeable future. But all these tools just help us and maybe make sure we don't miss anything.
Okay. Artificial intelligence tools are used to locate structural surface defects.
So for the most part, we're using the AI detectors for the crack detection and spall detection. Those are the two big ones. But again, we can train it for really anything that you can see in a photograph. You can train the AI to find those.
Okay. And do you foresee a time when digital remote images can replace arm's length inspection of defects in non-redundant structural tension members?
No, I still would not go there. Like I said, we just view it as a tool. It's not to replace inspectors. It's just to enhance what they can get to access-wise and data imagery. But yeah, you can't replace the human aspect of this for sure.
Okay.
Well, I agree with Jen completely, but I think one of the things where you could do that is maybe you have a bridge that has a lot of defects. You're worried about it. You could have an automated drone flight go out there every week or 2 weeks or a month.
Yep.
And do an automated inspection in addition to our normal field work. So that's maybe one area where you could take advantage of that, but it would be in addition to what we're normally doing.
Mm-hmm.
Okay. That question was directed to the non-redundant members, the tension members. We used to call them fracture critical, but I guess you could locate where your splices are, where they could, spend extra time looking at the beam splice areas. You could do all that. That would work. But then that question was directed toward the fracture critical or non-redundant members. But do you foresee it that you'd ever be able to do it for just regular bridges, replace the inspection? You think that's still going to be there?
Well, that's up to federal highway, isn't it?
Yeah, I guess so. Yeah, that was another question that came in during the session about will FHWA accept drone inspections yet? And
I know they accept them as a tool, but not to replace inspectors. And I feel the same way. I would not.
Okay.
To replace an actual inspection with a drone inspection.
Then there's a question here that says, if we use digital twins to assess bridge safety, which sensors are most suitable for providing data to the digital twin?
Well, the one we're using the most is just our regular red, green, blue, or RGB camera, which is just our normal images. And that, most inspections are, 90% visual. So the camera itself is the most important tool, and then we showed the IR tool as well. But then, one thing maybe we didn't talk so much about is that we can start incorporating a lot of the testing data, or if we have sensors on a bridge, into that digital twin and add them so that all of the testing information or sensor information is in one place with all of the inspection data.
Okay, there was a question about, is the data scattered all around, or is it all in one place now? So that came in during the presentation. Then what are the storage data and access requirements to implement this kind of system?
Yeah, that's a good question, a question that comes up a lot. And these models, especially some of the bigger, where we're doing the major bridge crossings or major bridges, the data can get pretty big, in the order of terabytes for a model and all the inspection data. And that, I think, can scare people. But like Jen and I have worked with Microsoft Azure, which is where they store the data through Bentley. And to them, that's not a lot of data at all. Like in maybe the bridge industry, it feels like a lot to us, but to the IT industry in general, that's not a lot of data. So I mean, we have stored everything that we've done, and it's still all accessible, and the cost really isn't that significant to do that.
Okay. How are you keeping data protected from bots and AI model attacks?
I guess it kind of goes along with the same thing that we just discussed is, we're using it through Bentley. They're using Microsoft Azure. So that's about the most secure platform that we can do. So we're sort of relying on them to protect the data, and we're not storing it locally. We're passing that off to people who know better, such as Microsoft.
Okay, and does the in the data, does it demand or require high-end hardware to use without freezing or crashing?
What we're using is the Skydio drones for the most part, the Skydio X10 now. And we also have a lot of Skydio S2s. The S2s are, on the order of a few $1,000s. The X10 is probably around $15,000 or $20,000, which, it's still, some significant amount of money. But when we're comparing it to things like snoopers for bridges that are $1 million, it's really not that significant of a cost to have and the X10 is a pretty high end drone. So it's to me that it's a fairly reasonable cost.
Okay. Can we use digital twins to do dynamic loading tests for bridges?
We haven't done that ourselves. I have seen that there's a platform out there that I guess would be, I don't know if it's technically a digital twin, but it's where you can measure like deflections and use that for the dynamic load testing or measure deflections. So I believe you can do that. We haven't done that ourselves.
Okay. Here's another one. It says, we have found drone imagery / software struggles to model cables to a usable resolution. Do you use photometric models to determine cable conditions, or are you still using rope access or other alternative methods?
I mean, I would say we're almost always using both, but nice thing is that when we're creating a digital twin, the basis of that digital twin is always the high resolution images. So we can view the cables through the images, even if they don't show up that great in the digital twin. And that sometimes is the case. The other thing I'll add is that there's kind of a new method of post-processing some of this data called Gaussian splatting. And that method will show the cables very well and show things like fence and real small diameter components much better than the old way. And so we're starting to use that as well.
Okay. Question came in during the presentation. It says, how accurate are measurements in the digital twins that are created by the drone scans? Jennifer, you mentioned 1/8 of an inch. Can you get better than that?
Well, I think Barrett can answer that better than I can.
Okay.
When I said less than 1/8 of an inch, what did you said something yesterday about more accuracy?
Yeah, I mean, I would agree that, and I mean, we routinely can get, to a few hundredths, and it's just a matter of how close you fly to the bridge. With the X10 Skydio drone, we're usually between 10 and 20 feet from the bridge, and then how good of a sensor the camera has. So that's what determines the accuracy. The other thing we do is we always try to put a scale on the bridge so that we can verify the accuracy in the digital twin afterwards.
Okay. Yeah, a couple questions about cracks. It says, are the cracks annotated at all, or does the Bentley iTwin capture them well? And what is the smallest crack that can be detected?
That's a good question. Technically, you can catch any crack as small as something you would see at arm's length. But the trade-off is that you have to really fly close to the bridge to do that, and so it's always just a matter of what is the kind of the sweet spot of that really high quality versus time and budget and things. But there's really no limit to what we can see other than just kind of a practical limit, because if we're flying a bridge from 5 feet away, that's a large bridge, it would just take too long to do. But there's really not a practical, or there's not a technical limit to what we can see as long as the camera can see it.
Okay, and then there was another wrinkle on that is, will iTwin quantify the cracks for bidding purposes?
Yes, it will, and it will classify them by width, and it'll give us lengths as well, so we can use that for quantities. And I would, we get that question a lot, and how accurate is the AI? And it's probably not completely accurate, but it's fairly accurate. But I would say it's more accurate than people because trying to measure even one crack that changes width throughout the crack and goes 10 different directions, like how do you do that manually without some kind of approximation?
Okay. And then the other question was what is the minimum width you can measure? You said you could quantify the width.
Yeah, again, it's just a matter of how close we fly. So it's we can fly really close and see really small cracks, but that's just usually not practical on a large bridge. But it's easier to show what that looks like. But I would say we're seeing all the cracks we would normally see if we're reasonably close to the bridge ourselves.
Okay. It's a little more than 10 after. I'm going to turn it over to Bijan and see if we can get a few more of the questions that came in during the presentation. So, Bijan?
Okay, thank you, Paul. Thank you for a great presentation. I got some questions that came to me from Kathy, and I'm going to go through some of those. We have just a few minutes left. The first question, is it possible to make a structural and analytical models directly from digital twin models?
That's a good question. I would say that there isn't a way to do that completely automatically, but we can import these digital twins into CAD and like technically you could convert it into a finite element model. But I think more importantly, we're just using the models to get all of the dimensions that we need to make a structural model. So even if it's not automatic, we're maybe measuring members and then inputting that into the structural model. And one of the benefits is like if somebody goes out and inspects a bridge for a load rating and maybe they miss some measurements that they didn't know they needed, you don't have to go back out in the field. You can use the digital twin to fill in maybe some of that missing data.
Good, thank you. Another question, Paul already asked you about the cracks, but this question, it says, can crack be determined through pavement and membrane?
No, because if it's not visual, then we don't have sensors that could like see through the pavement or membrane.
Okay, there is a similar question, but this is about the spall. Can the drone or digital twin determine the depth of the spall?
Yes, we can do that. We can measure that in the model or in CAD.
Okay. What percentage of the structures in the state have digital twin? I think that probably is for Jennifer.
Well, we have about, was it 300? So a very small portion right now, since we have over 20,000 bridges that we consider bridges in the state, which is 10 feet and over, as opposed to 20 feet and over as defined by federal highway and the NBIS. But yeah, we have about 300. So it's really a small percentage still, but a lot more than quite a few years ago. So we're slowly getting there. Mainly trying to capture the big structures for sure.
But you are ahead of many states anyway. Okay, during drone inspection, have there been any challenges or safety concern when traffic is running?
Yeah, I mean, we do have to be careful around traffic and around pedestrians, because obviously we don't want to run into a vehicle or people. When I showed, like, for instance, when I showed that we were doing the 3D scans of the bridges, usually what we'll do is we'll do the one mission that's from the deck below and then another mission from the deck above, and we'll offset it so that it doesn't go lower than like the height of a semi. So we might go 20 or 25 feet above so that we're avoiding traffic. We do also have to be careful that we're not flying over traffic, but as long as it's not like freeway level traffic, we can pause a mission, move out of the way, and then move back to finish collecting data so that we're not flying over traffic.
Okay, thanks. One question is, can these technologies be effective in post-tension bridge inspection, especially in identifying corrosion or grout voids? in the ducts?
Well, if you can't see it visually, then it probably wouldn't be helpful. I mean, you may be able to use infrared in some cases to do that, but you're probably also going to want to incorporate other types of testing technologies to find those types of defects.
Maybe last question according to the time. With the underwater sonar, can the bottom of the river bed or stream topography be captured to create hydraulic cross sections?
Yes, and we do that quite often. Sometimes in conjunction with doing a digital twin above the water, but a lot of times just capturing the below water. Collins does a lot of underwater inspections for Minnesota and other states, and we capture that topography data or hydrography data underneath and get looking for scour holes and things like that. So yeah, we do that quite often.
Kathy, I see you are there.
So I just wanted to, again, thank our presenters for sharing your time and expertise. It was a really interesting presentation. A reminder that the presentation will be archived on the website, so you can look at it again in the future. And also thank you to Paul and Bijan for helping moderate the question and answer. Back to what I mentioned in the beginning, if you do have any ideas for future webinars, please do email me. My email address is kakrowel@fiu.edu. Thank you again all for joining us today. The webinar is now concluded. Thank you.